Hello everyone. Today I going to give you the brief overview of machine learning models. So what is ML model? Actually a mathematical system that learns patterns from data and use those patterns to predict, classify, group, recommend, detect anomalies and generate content. Suppose a teacher observes low study hours and low marks, high study hours, high marks. The teacher learns the pattern like more study, more marks, and predicts marks for new students. So this learning system behaves like an ML model. So ML model do the same thing, learn pattern from the data and predict for new data. Okay. So core idea is like data, pattern learning, and intelligent decision. So this is the basic definition of ML model. So you can say this is the beginning of the uh, uh, modern generative models, very initial state, the ML model. Now we have to know how many types of learning, basic learning we have to train the model, right? When you're going to create a model, ML model, you need to train your model so that it can learn pattern from the data. Okay. So basically there are two types of learning model. So one is supervised model, another one is unsupervised model. In supervised model, data type is labeled. Means for every input there is associate output. Like about 2 hours is the study. It means if you input is 2 hours study hour, so your output is 50 marks. Means if you study 2 hours, then you will get you got the 50 marks. So this kind of data we input to train the ML model. That means the correct answer is known. The model maps input to the known level output to learn the pattern effectively. In case of supervised unsupervised model, here data is unlabeled. That means only input data is given, but no output is associated with the input data. So that means, uh, for example, customer shopping data without any category labels. Okay, that means the model have to discover the hidden groups, similarities, and underlying patterns on its own without predefined answer. Understand? Now move to the next slide. Now let's have a look different type of ML category. One is predictive model. Purpose predict future values. Classification model predict categories. Clustering models group similar data. Recommendation model suggest items. Anomaly detection model detect unusual behavior. Generative model generate new content. Reinforcement model learn using reward. Okay. Later I will explain all these model in detail with example as well. The main intention of this tutorial is to just at least you know the how many type model, okay, when to use what model, the basic idea. So first start with the predictive models. Basically used to predict numbers or future values. Like if you input an input, then you will get the numeric output. Here the model learns the continuous mathematical relationship between variables. For example, if you input house size, it will predict house price. If you input study hours, it will output marks. Temperature, if you input temperature, you will get electricity usage. But to train your model, you have to give the data like house price size with the associated house price. Similarly, study hours with marks, temperature with electricity. So that whenever new value will given to this model, it will give you the numeric value as the output. So in that case, relation is very condensed and simple linear kind of relation. So different algorithm is available uh, for predictive model. Algorithm is actually whenever you are going to create any ML model, predictive model. So you have to choose one algorithm based on your use case. You have to choose the proper algorithm. Start with linear regression. This is simple straight line prediction. Very simple. Polynomial curved relations. That means multiple dependencies you can say. Random forest dictation, the complex kind of prediction, not straight line. Okay. XGBoost regression, high business accuracy. Based on your use case, you have to choose the model uh, algorithm. Sometimes also we call the model. Okay. Don't get confused. Now coming to linear regression. Based on simple linear relationship, as I said. Example study hours if you and marks. If you input study hours, it will give you the marks. Why you use very simple and highly efficient, fast to train and deploy, and highly interpretable result. This is a mathematical equation. Based on this formula, actually, model predict the output. A simple linear equation. Like input variable, y the prediction and output, m is log, and b is the starting point. What you can say, y intercept. Now coming to classification model. Purpose is predict categories or classes. If you input a value, then it will give the output the category. For example, suppose if you input an email, it will classify like whether it is spam or not spam. Either it will output spam or not spam. Medical data provide a disease or health. Transaction is a fraud or safe. Okay. For this type of use case, you can use classification model. For example, model like logistic regression, simple classification, we can use classification, decision tree, and human readable rules. Then I'll discuss everything. Okay. Random forest, powerful classification. Actually, random forest use a lots of decision trees internally. Naive base, the probability base. You can remember if previous tutorial uh, discuss about the base theory and probability, right? Actually, it use base theorem to predict the output. This is SVM, the boundary separation. Neural network complex classification. This is the example model of classification. Based on your use case, you have to choose the correct model. For example, logistic regression. Uh, this is a binary classification is used to detect spam message. Output like is give you the this kind of quality output. Okay, so you use a fast, indefeasible, and poverty based. Very simple. And support pattern machine or SBM, as I mentioned in that list, is SBM, a boundary of separation. Find a base boundary between classes. Example, separate cats, dogs. Why use? They're powerful for small dataset and creates highly effective classification boundaries. Now, trees and forests. First one is decision trees. Makes rule-based classification. Example, loan approval. Thing like if salary high and credit good, then approval. Okay, so it actually uh, uh, three like decision to checks. First, it check one condition like if salary high, okay, it's passed. Then then next step is it will check your credit. If it is good, then it will approve. Finally, it will approve the loan. If the first step, if your salary is not high, then it will go to the another branch like it will not approve loan. So yes, no kind of branch, two branch uh, create from this first step. Then again two branch like this way, like this structure. And for use, easy to understand because it will show you the visual how it works, okay, how we decided the output, okay. And the next one is random forest. Actually, it use many reason trees together. Many trees brought together to finalize an output. So many trees separate individually find the output and based on the voting, it will decide the final output. I use high accuracy, reduce overfitting, works exceptionally well on tabular data. Okay. Now main base. As I said that the poly based calculation is use the base theorem. And remember in the poly session I have already explained the base theorem. The base theorem formula. I use incredibly fast processing works extremely well for test classification simple probability logic. And in this picture, we have just explained how we calculate the probability. Okay, I'm not explaining this calculation because in the earlier tutorial I already explained the base theorem. Then clustering model. The clustering model is a it groups the similar data automatically. Actually, it is a non-predictive model. Before before this, the classification and mitigation all the forward based model, but clustering model is non-predictive model. It is used for customer. It's group the different type of customer who are in a buying behavior. Okay, for movies, categorize the movies. Okay, same categorize the images. It creates different groups. Popular model K means baby scan, hierarchical. So these three type of popular models available. Also, some specialized ML models present. Recommendation model suggest product or content. Like in Netflix, it suggests automatically some movies and based on your recent. I mean, based on your movie you have watched, it will suggest automatically same type of movies. In Amazon also, if you buy some product, then it automatically will recommend you similar kind of product. Same for YouTube as well. So actually, the popular models like collaborative filtering, matrix factorization, deep recommenders. So based on the complexity, you can choose any model. Again, I'm saying later on I will pick one AP model one by one and explain and also give you the demo how to create the same. Next is anomaly detection model. Detect unusual behavior like suppose banking transaction is a fraud or not, cyber security is hacking or not, or manufacturing machine failure. Popular model isolation forest, one class FBA, auto encoders. Now advanced models like generative model, you may know that GPT, GANs, diffusion model. Okay, uses like to generate new content. Like if you just give prompt like image or question, okay, it can generate text, lyrics, music, everything. Another one is reinforcement model learning. Purpose learn using reward and punishment. Okay, action, reward or penalty, and better strategy. This is the workflow of this reinforcement learning model. And used for diving algorithm, winning in KCI, winning strategies, robotics, complex movement. These are the use case you can say. In this type of use case, you can use reinforcement learning model. Now let's have a look at the tabular format. When to use which model? So you have to predict number. Then you choose regression. Why? Because it's numeric out. Predict category, classification, because specific class level. Grouping customer, clustering model based on your similarity group. Recommend movies, special model, recommendation model, because it provides personalized suggestion. If you detect fraud, then anomaly detection, error detection, didn't even text, generative AI. Another table for model selection. Identification model, when to use linear memory prediction. Why? Simple and interpretable. Logistic regression for binary classification, because it's a fast and probability. Division entry when rule-based logic, because easy to explanation. Random forest when your structured or tabular data, because it's a high accuracy. XGBoost for business tabular data. SVN for small data set. K means customer segmentation. Neural network, image, text, or audio. The deep neural network has deep learning power, more advanced. So that's all for today. And in next learning video, I'll try some new things, interesting things, or it will be